Today, I just want to talk to you guys a little bit about compression and EQ because we don't really get into it too much. What is actually compression and EQ? What does it mean? So, concerning compression basically is a way that we can use an electronic device to control the dynamic levels of things. For instance, rather than having to have our hand on the knob of a volume knob, and if things get too loud, we got to turn it down real quick. If things are too quiet, we got to turn it up a little bit. Rather than do that, we can make devices that will actually anticipate our needs for that. And as the sound goes through it, it can go, oh, this needs to turn up. Oh, this needs to turn down. And we can control how much that happens. And so, yeah, this is an extremely useful device when we're doing all kinds of stuff when recording. Some with recording, but mostly with mixing. Mixing, this is where we really want to sort of control the levels and the dynamic ranges, because this is really what we're talking about here, having control over dynamic ranges. Let's talk a little bit about what that means here. All right, because what we need is good signal in general, and when we're mixing, we want all of our tracks to be of good signal. So having a good signal is pretty much what we deal with here all the time. A lot of times when you have transients, really fast, sudden sort of hits like that, that can really easily create an overage. So we want to make sure that they don't go over. We can attenuate those. So if it goes, we can turn it down when it gets too loud. But then also if we turn things down too much, and then there's low level information that gets lost in the translation. So if we want to have a great signal, we want to boost that low level information up so that we have a good signal to noise ratio across the board, whatever the format is. We want a robust signal. We don't want things to go too high and too low. So the result of this is that we need to make a narrower dynamic range for our instruments, and that's when we use compressors. I know a lot of times we talk about wanting to expand the dynamic ranges. So we have very, very quiet quiets and very, very loud louds. But really when we're dealing with tracks and trying to put a bunch of tracks together into a large mix, now we are talking about controlling these environments much more and sort of making sure that we have good signal for each of our tracks. So we need a machine that's going to do that. And so your perfect true compressor, of course, is going to be one that every time things get too loud past a certain threshold, that's that line that's in the middle of the graph down there, your sound gets past that threshold, then if it gets too loud, it'll turn it down. If it's too soft, it turns it up. So a perfect compressor knows exactly how to do that, how to make sure that the soft stuff gets louder, the loud stuff gets softer. And of course, if you really needed to, you could have a device that did the opposite. You could make stuff get louder over the threshold, quieter under the threshold. That gives us four states of dynamic range change. There's downward compression, there's upward compression, there's downward expansion, upward expansion. So what this means is that downward compression is that once it goes over the threshold, we're going to start bringing down. We're going to attenuate. Upward compression means if it's underneath the threshold, then we're going to bring it up. Downward expansion means when it's under the threshold, we're going to bring it down more. And when an upward expansion is over the threshold, we're going to crank it up even more. So these are ways that we can expand and contract our dynamic range. Okay, upward expansion right off the bat. Are you crazy? Have a device that once your signal gets over a certain threshold, it gets louder, you'll break stuff. That's crazy. We don't need upward expansion, so take it off the table. Downward expansion, yes, we do that. That's called expansion. So that anything underneath a certain threshold is going to be turned down. So we're expanding the dynamic range by doing that. So we can have a thing called an expander or a gate. So we do that. We don't do upward compression, which means bringing up things underneath the threshold constantly. Because imagine how hard it is for something to do that, to always sort of maintain a certain level as the level underneath is changing. That's, if you think about upward compression, you sort of, after a while you go, wow, that's just not going to happen. So don't worry about it. We're not going to have that happen. What we're going to really be able to do, if we want to bring up the stuff that's below the threshold, what we want to do is we want to downward compress and then bring up the level of everything. And that brings up the lower level stuff below the threshold. So really the main compression that we use is this last one here, or here. It's downward compression. That means once our signal gets to a certain threshold, we're going to start attenuating it. So compression really, for the most part, is about bringing down the level. That's essentially what a compressor does. Of course, what we want to do a lot of times is bring down the level so that we can bring up the level. We bring down all the transients, all the things that are hitting the overages, all the things that's going to get loud past the threshold. We bring those down, and then we can bring everything else up. We get more program information, and we get a more interesting and robust signal. We have more control over it, and it's a narrower dynamic range. All right, so what does this mean for us? Let's look and see what we can do with that, because here's our typical compressor in ProTools that comes with the factory, and it's a very straightforward piece of gear. We have really mainly these 6 controls. The threshold, of course, determines how high a level or how low a level we're going to start doing this attenuation. So we'll set the threshold to figure out, because if we have a certain level that we want it to be at. This gain button then, if we then start attenuating things, then we can then use this gain button right here to turn everything back up louder again. So anything that then passes this threshold is going to be affected by this ratio. So for instance, if we're at 3-to-1 ratio, that means when your signal gets past this threshold, it's going to be turned down. For every 3 dBs, you'll get 1 dB. If it's 1-to-1, it's straight. It's just straight, and everything it's even. If we go 2-to-1, then for every 2 dBs that goes over the level, it's 1 dB that's allowed through. And when we get to a 10-to-1 and up, then we have what we call a limiter. And so what we're not limiting right now, we're pretty much compressing. We're just going to be attenuating. We're not creating a brick wall here. So we'll have our ratio. Let's keep our ratio right about 3. Let's make it 4-to-1. And then we have this attack and release. And the attack basically tells us, once we pass that threshold, how quickly is it going to do this attenuation for us? How fast is it going to happen? So as soon as the signal passes this threshold, it's going to take 10 milliseconds right here for it to begin attenuating. Now we can make that be 300 milliseconds. We can have a super long attack. We can have a super short attack, 10 microseconds. So that's how fast it takes for this thing to go into effect once it passes the threshold. 1 millisecond. All right, then our release time, basically tells us once we get passed down on the other side of this threshold, how long it's going to take for this thing to stop doing what it does. We can use these 4 effects to pretty much achieve everything we need, and use this gain knob to bring it back up to a different level. And then this knee basically tells us how smoothly it's going to happen. Watch when I move this knee up, it sort of smooths it out. A soft knee means that the compression is going to sort of kick in very smoothly. We're not going to hear it really happen very, very suddenly. But with a hard knee like this, then as soon as we hit that threshold, we can make that sound very obvious that it's all of a sudden kicking it down. So if the soft knee is much more for mellower work, the hard knee is for something more intensive. And we'll talk about sidechain another time, but that gets us through these main 6 here. How do we utilize this? All right, so I've got my kick drum, and what I'm going to do is I've got this routed right now. So this kick drum is going to come out a bus called kick comp, and then it's going to go in this track here through the kick comp, and it's going to go into a new track. Listening to that in input, we are going to compress this kick and then record it, and then we'll be able to see exactly what we're doing to it. Let's just put it on this area here. So you can see here that we have the input. Let's go ahead and set it so the threshold is not super crazy. As you can see, as I pull this down, you see this gain reduction is happening more. That little orange thing is really lighting up. Oh, I should put that somewhere else. Hang on. How about I put this over here? When I put that threshold low, it's really reducing the gain a lot. So I don't know if I'm going to want it to reduce it 6 dB every time it comes through. Let's say I just wanted to reduce it about 3 dB. See, it's about hitting about 3 dB there. So when it hits this threshold, it's very quickly with this attack pulling it down 3 dB, as you can see over here. All right. It's a pretty fast release right now. So let's record that. Let's just see what that looks like when we do that. I'm going to put this in record. Okay, now look here what happened. As you can see, these are the same notes, but everything's been turned down. And so everything that gets past pretty much this point right here, it's been very much equalized and level. So what I've done here actually is what I might want to do, for instance, with a compressor. All of these are at different levels up here. They're all coming through at different levels. Now let's say I wanted them to be more evened out. So I put them through the compressor. I make it so they bring all the peaks down 3 dB, and now I've got all of these equal or even. But you might have noticed also that everything's quieter. So in this case, what I can do, obviously I can use clip gain and bring this up. And if I do that, watch, and you can see that I've got all this extra information. Let's zoom in a little bit here. I've made my peaks come down a bit. I've evened out all my drums, and I've also brought up, because I brought up the level of everything, I brought up all this extra program information here. So now instead of this little tiny bit I have up here, I've got this more stuff here. I've got my transients more controlled, and I should have more tone here. As a result of this, I've got an evened kick drum, and I brought out more of the tone of the drum. Let's do a little taste test here. I'll go back and forth between the two here. So this is the new one, compressed and not compressed. Pretty much the same level. I can even bring this one up a little bit. So you can see why we might use a compressor on a kick drum. We get a sort of a nice little 2-for-1 special here. We get evened out hits, and we also, because we brought everything down with attenuation, then we brought everything back up again when we turned up the clip gain, and we got some more stuff. Now we can also do this without doing it with the clip gain, because that's what this gain knob is here for. This is our makeup gain knob. So let's do this way now. Let me get rid of this. Now this time I'm going to do some makeup gain because I took 3 dB out. Let's bring up 3 dB back, or roughly that much. Okay, let's try that. Let's put in record. Bring that up a little bit more. Let's actually jack it up to more like 5 dB. Okay, as we can see here, I've got, it's almost the same level. I can even bring it up a little bit more with the makeup gain, but we've attenuated the peaks, and we've been able to bring up the body of this kick drum. And actually, I think we've got a better kick drum as a result of that. So that's why we might use a compressor on a kick drum. And same thing with the snare. We get the same kind of effect with the snare. We can sort of control the transients just a little more. We don't want to do it too much because we still want them to be nice and spiky and really sort of pierce through. But then we can bring up the program information on the back. Same with toms. Same with all kinds of stuff. Now, compression, obviously, we can use it on vocals. This is also really good to use on bass. It levels out bass. It does the same thing. We can sort of control the transients and bring up the overall level, and it really levels out the bass. These are going to be some of the main ways that you want to use compression. It's just a good way to control and limit the dynamic range of things. All right, next up, I want to sort of talk a little bit about EQ, because again, we're sort of giving you a lot of the quick and dirty about compression and EQ, and we might as well do it with drums while we're here. I'm going to pull up the EQ that comes with Pro Tools, the good old 7-band EQ, and it's actually 5-band EQ with two filters. And so let me sort of discuss what happens with this. Okay, equalization, just to sort of give you a quick little history about it. When we first had telephones, the idea about equalization, and the reason why we call it that, is that when we had a signal on one end, it usually came out the other end diminished, not sounding so good. It didn't sound like Uncle Phil talking in the phone. It sounded like, so basically what they would do is that, well, let's add extra high-end frequencies on the front end, so then when it gets to the other end, we'll have a regular amount of high frequencies at the other end, since we're losing high frequencies in this process. So the equalization was applied at the beginning of things on the transmission end, so that it would end up proper on the end. Nowadays, equalization is really more spectral management. It's not really, we're not equalizing things as much as we are changing the spectral shape of things. We're looking at the entire spectral shape of our sound, the low end, the mid-range, the upper mid-range, and high end, applying levels and amplitudes to different frequency bands. Different frequency bands get turned up or down, cut or boost. Those are the terms we use. And then we boost and cut with curve. Here's a boost of 1K. And as you can see, it's a nice gentle slope right now, but let's say I want that to be a narrow slope. So we have this thing called Q right here that we see right here is underneath the letter here. It says Q. And this Q right here is 1 if we turn it up. The higher the number of the Q, the narrower the band. So we can narrow that band. It can be broad or narrow. So those are the EQs that we can use in the middle. And this is a parametric EQ. It has 5 main bands. So we can have bells in the middle. We can have bells on the ends as well. Or on the high and low end, we have this other option called shelving. We're getting all the frequencies over that or underneath it. And that happens on this end as well. We can do that with this end, so that's shelving on the low end or high end. And we have, and those can also be changed over to bells too. So we can be making those bells as well. So we have 5 different options in the middle here for different frequency band ranges, ranging from 20 hertz to 20 kHz. That's of hearing. And on top of that, we have high pass and low pass filters. And these are very important for EQs. We really, especially the high pass filter, because in a lot of our tracks, we find there's a lot of low end information that's in the track underneath 50 hertz that we don't even hear, that's still there and still does stuff and it's still there. We can't really hear it that well, but it's still screwing up our mixes. We want to get rid of it, so we use those a lot. So in this case, here's our high pass filter. Let me engage it. And it's a gentle slope of minus 6 dB per octave. We can make that a steeper slope here, a very steep slope. And when we do this, we are getting rid of what's underneath it. We're not just attenuating it, we're getting rid of it. So a lot of times we're going to use these a lot on a lot of our tracks. Almost everything that's not a bass or a kick drum is going to have a little bit of this kind of filtering on it if we're smart. We can have low pass filtering too, the same kind of thing, and we can adjust the frequency so we can really sort of narrow this in if we want to. But those are our filtering options. How would we want to use our EQ? There's a couple of ways to do it. Think about it. Number one, to use EQ to make things more, to sort of bring out frequencies to make a better sounding sound out of your sound, making more of it, bringing weight to it. There's also taking out the bad frequencies. There's also notching out things that we don't want to hear. Certain frequencies that are present that we feel are not helping us. Those are really pretty much the 2 main ones. And sometimes we use it to do musical things. But the main thing is cutting and boosting to make the most of the sounds. And a lot of times we're also cutting frequencies out of sounds so they can fit with other sounds so we don't have masking. Because one of the things we learn about mixing is that we're always fighting masking. If we have 2 sounds that overlap in spectral content, one of them can mask the other if it's louder than the other. And if we can clear out some of this extra frequencies that overlap and give them their own spaces, then they'll speak out better. So this is why we want to use EQ. I'm not going to get too specific into it, but let's look at how we can make this kick drum a better thing, for instance, using EQ. All right, so I've got my compressed kick drum. Let's get back over to it. Let's see if we can't make this a nicer tone here. So right off the bat, I think what I'm going to want to do with this kick drum, I'm going to want to get some boom out of it, some oof. So, and I don't think I would necessarily want to do this with a shelving. I don't want to bring up all this extra crap underneath. So I'm going to turn my low thing into a bell curve, and I'm going to bring up, and I'm going to just, when I bring that up down there, you can all of a sudden really hear some things booming. Now, if I'm up here around 100, it's really kind of, you hear even an impact, but it doesn't have the boom. We get the boom more down here around 80 or 50 or 60. So let's get a little bit of that. Let's not get too much of that. I'd say about 3 dB. And let's bypass that not give it a little. Okay, we can see that we're already getting some overages in our out here. So let's go back to our track here. And this is when we're also going to probably come back here and clip gain it down some. But I'd say about 3 dB. Let's clip gain it. All right, and keep listening. Cool. Much better. Now, the other thing that we want to do with the kick drum, a lot of times, is really get that impact, the impact of the click. And that's going to be up here around 5 or so. And let's go and do a shelving up here around 5. And I'll pick that up. Let's hear it. I'm soloing it. Let's see if I can pull out a little bit of... See, here's this stuff here. I don't want it not so much. That's sort of a paperiness. All right, here, right, this stuff. Let's get rid of some of that. Let's bypass it. That's what we started with. And now we got a little more thump. We got a little more smack to it. And we got rid of some of the paper. So that's how we can sort of definitely approach doing a kick drum with the EQ. Let's look at doing the snare drum while we're here. Let's put a little EQ on this. And this time let's use the Ozone 9. Let's look at the Ozone 9. And now we can even see it this time. So here's our snare drum. And look at all of this junk down here under 100. We don't want any of that. That's not going to help us. So right off the bat, we're going to filter that, just using the filter. Okay, then for instance, for the snare drum, we might want to get a little bit of the impact. Let's see if we can find that. I feel like it's right by here. We're getting some impact. Right around that. Let's open that up a bit. Okay, and so let's just check out and see if we can't find some nice high-end stuff we can get out of that snare now. So I'm going to go ahead and get up here and just maybe put some nice little Baxendale treble on this. Bypass. And that's adding some nice high end to it. I'm kind of overdoing it a little bit. Again, let's see if there's some of this middle range stuff that we don't like. Let's take it out. So you can see we can sort of add some extra niceness to the snare drum. We get rid of all this ugliness over here that we don't want. So EQ, this is what we're going to use to sort of make some things happen with our sounds that make it just a little more, make things sort of fit together. Yeah, so we're going to make the most of some of our sounds, and then little by little we're going to sort of start using EQ to sort of help sculpt different sounds so they'll fit together. So these are two ways that to start approaching using compression and EQ, especially when we're using with drums. It gives you a good start, I hope, on how you can start approaching EQ and compression. All right. Thank you.